Here's argon right here, so that's our starting point. So remember, that shorthand notation means that all of these electrons before argon are being accounted for, including argon. So we only need to keep track of the new electrons that are being added in this row here, right? So we have 4s2 and 3d7. So if we look here, just a reminder, these two are our s, these ones are our d orbitals, and these are our p orbitals, right? So we fill up both of the s orbitals, right? So 4s2 tells us that both of these are knocked out, and then 3d7, so we just go like this. 3d1, 2, 3, 4, 5, 6, 7. So that's the seventh element in the 3d orbital, and that gives us CO, which is cobalt. That's how you do number 8, okay? So I'd recommend labeling your periodic table. Let me make it a little bit cleaner for you. Just a reminder, this is the S block. This right here is the start of the D block. And this right here is your P block. Okay, so that's how you count which electrons you're looking at. And then just remember that the period tells you the energy level for S and P, and then one less than that is where your D starts. Okay, so that's number 8. All right, number 9, click on the letter that shows the correct orbital diagram for vanadium. So again, let's take a look at our periodic table. Let's find vanadium. I find it right here. And so I have 23 electrons. So let's count our electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's good. Let's double check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so both have the correct number of electrons. So what we have to look at now is the last couple of electrons here. I notice, so this is our 3D orbitals, right? Because remember, S only has the 1, so we should recognize that. Make sure you're careful of that. So that S is right there. So these are all d orbitals. So 3d orbitals are all in the same energy level. So what we know about electrons is they don't like to be next to each other if they don't have to be. These ones are nice and spread out. This one partnered up early. This electron should be jumped over here, right? That means that B is our correct answer for number 9. Okay. Number 10, so largest to smallest atomic radius. So on your periodic table somewhere, you should have something like this, an arrow with increasing radius, and then an arrow like this showing decreasing radius. Okay. So what that means is increasing and then decreasing. So these are the biggest atoms. And then as we go this way, we get smaller and smaller, and these would be the smallest atoms. Now, let's go ahead and list these. So let's find our elements. So I have nitrogen, so I'm going to circle nitrogen. Phosphorus, I'm going to circle phosphorus. Fluorine's right here. And then we have potassium all the way down here. Let's go ahead and erase vanadium so we're not confused. If we look here now, we're trying to go what? Smallest to largest. Okay, so I remember if this is increasing, then up is smallest, right? So up here would be the smallest. So N and F are going to be small. And then they get smaller as we go this way. So over here. So fluorine is the highest up and farthest to the right. That makes it the smallest. So fluorine would be number 1. So that will be at the top. Next to it, we have nitrogen and then phosphorus, right? So we will have nitrogen number 2, phosphorus number 3, and then potassium is the biggest, okay? So again, I'm just following these arrows. I know that it gets smaller over here, right? And I know it gets smaller up here, so I know these are our smallest, and then I just start following them. So smallest, next smallest, next smallest, next smallest, so biggest. All right, let's try this for number 11. So we have electronegativity this time. So we have something on our periodic table maybe that looks like this. Okay, so increasing electronegativity. And then I believe this way we have also increasing electronegativity. Okay, so what does that mean? So if it gets higher as we go up and it gets higher as we go right, these are our most electronegative atoms, which means down here would be the lowest electronegative atoms, okay? So, and then look at that, we're going from highest to lowest, so it's perfect. We're just going to start in this corner and work our way across and down, across and down, across and down. So let's highlight the atoms we have. We have calcium, I see that right here. Carbon, that's going to be right here. Aluminum is right here. Oxygen is right here. Okay. So again, over here, right, biggest, and then because of this, biggest. So right here is our biggest. So that means we're just going to follow this order. So oxygen, then carbon, then aluminum, then calcium. That's simple, right? So start at the top right and then just work your way over and down, or over and down. So we should have had O as number 1 at the top. Carbon would have been next. Aluminum would have been third, and then calcium would be in last. Okay, that's what we should have done. And then not on this practice quiz, but still remember the dead guys. So we have Bohr. What did he do? What did he discover? Rutherford, right? What did he do? What did he discover? What experiment did he do? And then we have Thomson. I forget how to spell his name, something like that. What did he do? What did he discover? And then Dalton as well. Okay, so that's from one of our pages of notes. Just know what they did, what they discovered. And then don't forget about electrons and light energy, right? If you have a nucleus and some electrons around it. Okay, this is called the ground state because it's the lowest energy or most stable form of an atom. Sometimes, though, those electrons can jump up to higher energy levels, more unstable, right? So that would be the excited state. This is when they gain some energy, okay? And then just remember that this goes from this to this when energy goes into the electron. We don't see that happening, it just happens. We do see this though. When this jumps back down and goes back to the low energy state, that's when we see the release of light energy. Okay, so don't forget that as well. All right? Okay, good luck.